Hello everyone. Today's video is about normal distribution or Gaussian distribution, named after German mathematician Johann Carl Friedrich Gauss. Normal distribution is the important distribution in probability theory and statistics for independent random variables. The density function you can see in the Formula 1, where mu is mean of distribution and sigma is standard deviation. This distribution has a graphical representation as a bell curve. In Formula 2 and 3 you can see that mean mu is mathematical average of values and standard deviation is a measure of how dispersed the data in relation to the mean. A very important rule in statistics is the 68-95-99.7 rule. It is the empirical rule for the values that are within the interval estimate in a normal distribution. The 68% of the data are within one standard deviation, sigma, of the mean mu. 95% of the data is within two standard deviation, two times sigma of the mean. And 99.7 of the data is within three standard deviation, 3 times sigma of the mean mu. For analysis, I use the Excel. I have my 100 samples here. First column are numbers from 1 to 100 and example samples values. This can be tolerance measurement or failure time of parts. First, we will calculate a mean with Excel function average. Here in yellow notes, you can see Excel function in black. It is in German, and in blue color, it is English. Because my Excel has German language, and I only translate functions in English. So, mean of my data is 94.74. I round my results with function round without decimal place, 0. Next step is standard deviation. In Excel we have a function for this. This function is formula 3. Additional, I calculate first, second and third standard deviation from 68, 95, 99.7 rule. I copy formulas from my presentation. First deviation is mean mu plus standard deviation sigma. Second deviation is mu plus 2 times sigma, and third deviation is mu plus 3 times sigma. The same in another direction, only with minus sigma. No to normal distribution. Function in Excel, for this you can see in yellow note, it is the same Formula 1. You can use also Formula 1 for this. I create normal distribution of my data. To visualize, create the diagram with x data are number 1 to 100 and y data are normal distribution. Here is the bell curve of normal distribution. After this, we can create histogram from my data. A histogram is a visual representation of the distribution of the data. We compare the histogram with normal distribution and we will see is the data normal distributed or not. We can see my data are normal distributed. Of course, this is not always the case. In the next step, I want to combine both diagram, normal distribution and histogram, in one diagram. To do this, we need to calculate frequency. I defined the first bins for frequency. For this, I used first, second and third standard deviation. It is 20, 13, 14. Mean is 15, 16, 17 and 18. After this, we will calculate frequency for these bins. We mark rows for frequency opposite bins and give the function frequency, data array and bins array. Very important, to end this function, press Ctrl, Shift and Enter. Then Excel returns a vertical array of numbers. Now I duplicate the normal distribution diagram and add frequency. Bins on the x-axis and frequency on the y-axis. Change the normal distribution line to second axis. Next step, add error bars for frequency line. Remove horizontal error bars and change direction for vertical error bars to minus 100%. Change the color of bars to blue and thickness to 14. After this, make line invisible, so we have no frequency bars and normal distribution in one diagram. Additionally, we can add min line to our diagram. And finally, first, second and third deviation points. I create an Excel sheet with random values for samples, random between 1 and 100, and with key F9 generate the numbers and watch how the diagram's normal distribution and histogram change. In real process, we do not only have a normal distribution of data, we can make statements or estimation about process by evaluating the distributions. Normal distribution has bell shape, the data is symmetrical around the mean, and the frequency of the values decreases evenly. This process is stable. Example is manufacturing tolerance in production, maybe. By skewed left distribution, more data points below the mean, most values are grouped on the right side. Example is durability life of electronic components, because usually they have a long life, but a few components fail early. Skewed right distribution, most values are grouped on the left side. Example may be mechanical failures by sporadic overloads. Bimodal or the multimodal distribution are characterized by two or more peaks. The data has several subgroups. Example is different production machines or conditions create separate groups. Uniform distributions, all values have the same probability. Example is a random signal noise. And random distribution has not structure. The data is randomly distributed. It was for today. See you next time. Bye bye.